Okay, so now let's start with the first chapter in our Jupyter notebook. So that would be pretty basic introduction about the Python and the structures and standards and styles that we follow. So one of the basic things we have to consider about Python is that so it has a set of styling guide that's defined. So early 90s, not early 90s, late 90s, 1999, that it's called as Zen of Python or the Easter egg of Python. So these are the set of rules like any programmer who dives into the Python world should be considering and looking into it before start writing a program. So you can get this. So as you can see, import this. So if you write import this, so you'll get all the Zen of Python. So these are 20 set of Zen of Python. So let's see some of that and get inspired how exactly Python works. So they say beautiful is better than ugly. Yeah, so it's about readability. It defines something about the readability, saying that so the code should be beautiful enough and readable enough, and the explicit is better than implicit. So in Python, so whenever you write, so again this also focuses something towards readability of code. So whenever you write a module or something, so you either should be able to read uh, instead of just abstracting what you have written. So you should be able to get understand the code through whatever explicitly you write in the program. And simple is better than complex, yeah, for sure, why not? So you should write program in such a way that if you can write in a simple way, the same amount of code, that's same amount of output you can get, same output you can get. So you should be able to write it in a simple way. And so complex is better than, so you should not ever make it complicated. And although there might be a complex solution, the user should be able to get the complex solution. So we should not be making our code really complicated for anyone to understand. Flat is better than nested. Yeah, so if the beautiful example would be writing a set of if statements. So you can write a set of if statements rather than nestedly putting one if statements inside other. So these are like, you can go through all of them now. So the one more important thing, the error should not pass silently. So in Python we never ever just print error or log an error. You do something about the error. So that means you always try to catch your exceptions. You try to do error something about the error. Yeah, so there are a lot of other so you can dig deep into these Zen of Python before diving into Python. Okay, so now let's get started with the basic syntaxes of you know for Python. So whenever you're in Python, so this is my terminal. So if you want to write run a Python, so what you do is you just write Python 3. You will be put into a REPL. So this is called as a Python shell. So you can write any number of statements and instantly it will give the answer instead of parsing through the entire set of statements. So for each statement you would get the answer. So for example, okay, so before that, so as I already told, the notebook also runs all the, so here's the kernel specified. This is Python 3 kernel. And so there are a lot of options here that you can use. So you can edit the cells, insert cells, run cells, and you can change the kernel, restart, whatever you can do with this Jupyter. But whenever you want to run any lines of code, you just type run over here. You just run. You would get the output. So let's something went wrong. So let's restart this. So let's say you add more number and you run this, you would get 11 instead of previously. So whatever changes you make over here, it will be reflected instantly running through this Python kernel. And so this is so if you make any kind of error here, it would obviously throw an syntax error, just like the Python throws. So if you do the same exact thing over here, it would it would throw some kind of error. So similarly, this also throws an error. So yeah, so you run this way. Okay, so in the Python, when you write help statement, you would get the list of help summary. Okay, so as I was talking, this is a REPL, so you can write a number of statements just like we did over there. You would get the answer instantly rather than waiting for some amount of time. Okay, so now coming to the variables and values. So as we already told, Python, it's not typed language. So for data type, you don't have to define the data type. So whenever you assign something to the variable, so as you consider, let's say x is a variable, and you assign something to the variable, instantly it will identify that it's an integer. And when you define y and assign something, it will think that it's a variable, and you don't have to worry about anything. So the easiest example, so let's do the same thing over here. So you can, in Python, you just write type, you would get what type of data it is. So if you run this, something like let's clear all the cells and then try. So you can just output clear all the cells. So now if you run, so this ran. So if you want to write the output, just let's type print and then run it again. So this would give the output as integer, so it's an integer type. So the same thing, you can just write it over here. Let's write y and then run this. So yeah, this will give you str. That means it's this hey, that xy was a string type. Yeah, so this is how you identify the variable types in Python. Okay, similarly, assignments in Python could be just done with the single statement. So having multiple variable assignment, just x equal to y equal to 1. So this will assign 1 to both of them. So as you can see, if you run this, you'll get 1 1. Oh, that would be the output. So when you write x comma y, so we'll come to this later, this will form a tuple. So so if you want to do the type of this, okay, that was an error. So we can assign it to something and then check the type. Yeah, okay, that's still there. So let's assign this to z and then try to print this. Okay, still an error, so we'll look into that later. Okay, so let's continue. Yeah, so you basically in Python, so there are like basic types. So although it doesn't have a data types, so when you assign something, it will convert that particular object into particular having a data type. So the data types it has are float, int, string, boolean, and it does have long int, all those things. So so if you see, these are the boolean, these are string, and these are string, and so this is an integer limit, and this is a floating point. So whenever you define something in a decimal, it becomes a floating point. Yeah, and this is a complex variable. So let's run this. Okay, so it's just like 1 plus 2j. So this becomes the complex part or something. So there is a complex data types also in Python. Okay, so now coming to the operators. So just like any other logical, so it does have a lot of logical arithmetic operators. So some of them are given here. So addition, subtraction, you can do this model. So these are all arithmetic operations, multiplication, flow division, power, all those things. So we can just run all this and see how this works. And this would give so since both of them are integers, so you would get an output as integer. So if you have something like one of them as float, so when you run this, you would get in that is float decimal. It doesn't implicitly convert the data, that's what see. And so this is a reminder, and this is a flow division. Okay. And the floor division is nothing but it gives the floor value always in the division. So, and this is a reminder, it would give 5 as output, and this gives 11 to the power 300. It's pretty big. So as you can see, it doesn't have a limit in the output, so it's basically gives a really long integer in Python. And this would give a decimal output. Okay, this would give a out of range because there is a limit for the double. Integer doesn't have a limit, but double has a limit. So if you, it would give an answer, but double has a limit in it. And these are the relational, these are used to compare different values in Python. This is for equality, and these are for less than, greater than, all those things. So you can run a few of the stuffs and see. So this is how you just run these and just test. So if you write z less than, so this would again give false, but if you less than say 3, this would give true. And you can have a relational operator, something say this z value lies in between these two values, and this would give false. So if you write something like 6, this would give true. And these are boolean and logic. So these are the boolean operations. And so you can go through all the data types of Python. So it's quite similar to any other language, but quite simpler in a way. And so it has a lot of built-in functions, or you can convert the values of data types, like so you can convert from hex type of data to decimal, floating point number to integer to floating point. So you can basically convert floating point to integer using this. If you just run, you will get this, all of them in integer. And so you can convert this boolean into string. It will just output as true as a string. Everything you can convert into a string. And there are mathematical functions that you can use to perform. So there are a lot of arithmetic functions. So something like round, floor, complex, that we already see, abs value. So you can get absolute value of C, and you can do mod division, all those stuffs. So it's pretty evident that it could be used in a lot of data science, mathematical fields. So as it's already implemented a lot of places in mathematics. So you can check out this notebook. This will basically evaluate this. So how you accept a user input is, so in C we use scanf. In Python we just take input and we can either give integer input, raw in whatever, so it's basically a raw input. So now this particular will evaluate it. So let's write a type of, say, let's define something over here. Then let's define x equal to 1 and I'll run this. So there is again some, let's clear all the cells again. Okay, let's run this. Maybe it takes some time for this input to particularly occur sometimes. Okay, now we got it. So I'll write it down again. X equal to type of, okay, sorry, x equal to 10. Let's give some time. Let's run this. Now you write type of x. So this was basically eval function would evaluate this particular string and give the output. Sorry. You should press an enter after the raw input. So press an enter. You would get the type of x and it would be the output, like type int. So that's how the eval works. Okay, so this is all about the first chapter. So let's dive into the next chapter.